Two men report to the lab after a 12-hour fast and are given identical glasses of sugar water. Both men are 45 years old, have a BMI of 29, making them both overweight, and have a waist circumference of 94 centimeters. Despite them seeming quite similar on paper, for some reason Joel's blood glucose is higher than Matt's for the entirety of their 2-hour oral glucose tolerance test. The question becomes, why? As you can see, after ingestion of the same quantity of sugar water, Joel's blood glucose becomes more immediately elevated and takes longer to return to normal levels than Matt's does. This phenomenon is what we hypothesize to be the product of healthy obesity. This is a condition in which someone may have a BMI and waist circumference below the cutoffs for obesity, but are insulin insensitive, similar to the way an obese person might be. Our main hypothesis begins by characterizing our mass. We chose to use blood glucose as our mass, with the assumption that inflow of blood glucose is the same since both men consume the same drink. We hypothesize that the outflow of blood glucose through uptake into skeletal muscle is lower for Joel. This is likely due to mechanisms within the muscle, leading to Joel being less insulin sensitive. Insulin insensitivity is characterized by an impaired response of the insulin signaling pathway in skeletal muscle. Normally, this pathway is initiated when insulin is released from the liver in response to elevated blood glucose. In this case, ingestion of a sugar drink leads to this increase in blood glucose. Upon release, insulin reaches the skeletal muscle membrane, setting off a chain response in which IR subsequently phosphorylates IRS, which in turn leads to downstream activation of P13K, AKT, and eventually the deactivation of AS160. Once AS160 has been deactivated, GLUT4 receptors, stored as GLUT4 storage vesicles, are free to translocate to the skeletal muscle membrane. These vesicles travel along actin filaments by the transporter RAC, which has been activated upstream by P13K. This is a good model for glucose metabolism that we observe with Matt. Again, we hypothesize that Joel is insulin insensitive. Joel is likely less fit than Matt, meaning that he metabolizes fat at a lower rate during exercise and at rest. This means that when free fatty acids are brought into his skeletal muscle via the fat transporters, the pathway leading to these free fatty acids eventually being converted into intramuscular triglycerides has lower conductance. This is because triglycerides are being broken down more slowly. This leads to accumulation of the intermediates of this pathway, including DAGs, which have been implicated in inhibition of insulin signaling through deactivation of IRS. Also, free fatty acids are more likely to enter an alternate pathway, leading to accumulation of ceramides, which deactivate AKT in the insulin signaling pathway. Ultimately, this means that for a given release of insulin, Joel is able to uptake less glucose, necessitating higher releases of insulin to compensate. This leads to the result we see in the oral glucose tolerance test, with the initial glucose uptake response being delayed for Joel and blood glucose remaining higher throughout the test. Since Matt is more fit, he metabolizes these free fatty acids more efficiently and doesn't have the same accumulation of DAGs and ceramides, thus maintaining appropriate insulin sensitivity levels. Our hypothesis is supported by a paper by Goodpaster and colleagues in 2003. They found that after 16 weeks of training in obese adults, glucose disposal rates are higher in the trained condition, as well as insulin sensitivity. These results confirm our assertion that Matt is more fit than Joel and thus has a greater outflow for blood glucose through greater insulin sensitivity. An additional important result of this study was that the trained individuals had higher levels of fat oxidation, aligning with our hypothesis for the underlying mechanisms of insulin insensitivity in Joel.
Isn't it just a little bit suspicious that good paster is only 2 letters away from good paper?